All right, let's continue what we started yesterday. I'm gonna retrace our steps just a little bit so we have this thing to work with. Do you remember we did that long division problem with the 15 and the, 842? All right, let's just go through it a lot quicker than we did before. So we said, well, 15 doesn't go into 8, so we don't put anything here, but 15 does go into 84. It doesn't go at exactly a certain amount of times, but it does go 5 times. 5 times 15 is 75, so we subtract a 75 from this. Okay, we drop this down. We drop down a 9 when we subtract 84 minus 75, and then we drop down this 2. Now we say, how many times does 15 go into 92? It goes 6 times because 15 times 6 is 90. What do we do with that 90? We what? Subtract. Subtract, you get a 2. There's nothing else to bring down, so this is our what? Remainder. I'll write that down. This is our remainder. How do we write our answer with a remainder like this? We would write it 56 and what? 2 over 15. Everybody see that? Okay. We're going to use that as a guide to do what we're going to do today. I think we wrote it down yesterday, didn't we? Yeah. So I'll just try to pick up where we left off yesterday. Plus 4x squared plus x plus 7. Remember one of the last things we talked about yesterday was making sure that the stuff inside here was in descending order. Thank you. I always forget that word. I don't know why. But in descending order, and that there's no gaps. Somebody said, well, what does that mean there's no gaps? If you start with x cubed, you must have a what next to it? An x squared. And then after that, you must have an x to the first, or just x. Okay? And this one technically has an x there, even though we don't really see it. What would that be? X to the 0. So does it have everything? We've filled in all the gaps? Yeah. The reason I say that is not because of this problem, because of the next problem. All right? So I just want you thinking about that. Okay? All right. Now, we're ready to pick up where we ended yesterday. Here's what we're going to do. Look what we did here. We said, how many times does 15 go into or divide into 84? Correct? Here's what we're going to do here. We're going to say how many times, now this is not a 15, this is an x squared plus 1. It looks a lot different, doesn't it? But we're not going to look at the 1. I don't care about the 1.
If you printed in the upper school office, we have Bellringer who did the side paperwork, economics, a finance project, study guide for imperialism. Please pick up your stuff.
Okay. Anybody want to give odds for how many announcements are going to be the rest of the period? 5. So is 5 the over-under? I think that's pretty high. That might be pretty high. 4. Yeah, I go 2.5. I think that's a good over-under number. All right. Who's going over? Only one going over? Everybody else going under? Okay, we'll see. I don't know what I would say. How I'm feeling right now, I'd probably say over. All right, I'm wasting too much time. The announcements we're making. All right, so here we go. Instead of saying how many times does x squared plus 1 go into this, I'm just going to look at the x squared, okay? Forget the plus 1 for right now. We will include it in a little bit. So watch what we're doing. Instead of saying how many times does 15 divide into 84, I'm going to look at this and say how many times does x squared divide into 3x cubed. Did you follow me? Getting a lot of blank stares. What did we do here? We went, how many times does 15 divide into 84, correct? So I'm going to take the x squared and say, how many times does x squared divide into 3x cubed? You're like, well, I don't know. I think, to tell you the truth, I think it's easier to do this division than it is 84 divided by 15. I'd probably need my calculator for that. On this one, I don't need a calculator. So what am I doing? You could do it off to the side on the piece of paper, right, on your homework. You could do it off to I'll do it up here since I got a little more room up here. So what'd you do here? You went 84 divided by 15, didn't you? Now, it doesn't come out even, but that's basically what you did. All right? So what are we going to do here? Instead of 84 divided by 15, what are we going to do? 3x cubed, what? Divided by x squared. You got it. You're catching on. So 3x cubed divided by x squared. Again, why? Because I want to find out how many times does x squared divide, even, not, well, it will be even, but how many times does x squared divide into 3x cubed? That's how I write it right there. Does that make sense? Because this is kind of what we were doing, wasn't it? 84 divided by 15. Again, it doesn't come out even, but it comes out 5 point something, right? But at least we know it goes into it 5 times. Right here, what do? And we've learned how to do this. Well, it's 3 divided by 1, which is just what? 3. And an x cubed divided by x squared. So I got 3 x's here, and I got 2 down here. So 2 of these x's cancels out with what? With 2 of these. How many do I have left? Just 1x, so 3x. So when I say, how many times does x squared divide into 3x cubed, how many times does it go into it? 3x times, okay? And where would we put that? Yep, just put it right there. Does that make sense? Don't worry about it until the next step, okay? So don't worry about that plus 1 just yet. Everybody got that? So I'm just doing that. It's like that 5. Did I really worry about what was left over from this? No, so I'm not going to worry about what's left over from that. Do you see the correlation between the two? That's why I like to have this up in front of you so you can just bounce back and forth and see this one and compare it to this. After a while of doing these, my guess is you might like doing this better than you like doing this. Because I do. I'd much rather do this kind of thing. The arithmetic, I think, is so much easier doing this than it is doing this. Especially if you didn't have a calculator, okay? If you had a calculator, this is not that big of a deal. But this you can do without a calculator. This, you don't need it, but you could do it with a calculator. Anyway, let's keep going. Now, what did I do over here? I put the 5 up here just like I put the 3x up here, okay? What did I do with that 5 then? I went 5 times what? 15. So what do you think I'm going to do here?
3x.
Right, 3x. Now, here's the time when you're going to include that whole thing. So it's going to be 3x, not just times x squared, but 3x times x squared plus 1. All right? So again, we're going to keep jumping back and forth. 5 times 15 is what? 75. And what did we do with that 75? We did what? We subtracted. So what do you think we're going to do here? We're going to go 3x times x squared plus 1 and then subtract it. Okay? Let's do the multiplication. Let's do it off to the side. 3x. I really should. Tell you what, let's get rid of this. We've seen that already, so let's get rid of that. Okay? Just to give myself some more room. So let's take that 3x and multiply it by this x squared plus 1. After a while, and maybe even right now, some of you can just do that in your head. If not, I'm going to show you what you're doing. You're going 3x times x squared plus 1. Right? I'm going this times this, and then I'm going to subtract it from this. Just like I went 5 times 15, right? I got 75, and I subtracted it. So I'm going 3x times x squared plus 1, and I'm going to subtract it. But I got to figure out what that is. What is this? 3x times x squared is 3x cubed, plus 3x times 1, which is plus 3x. Okay? That right there is like me going 5 times 15. That was that step right there. I just wrote it down because, you know, you don't multiply stuff like that very often in your head. But then I subtracted that 75, didn't I? So I'm going to subtract this. Now, since there's two things, I'm going to put a parentheses. So the 3x times x squared plus 1 is what? 3x cubed plus, hang on a second. Oh, okay. Remember we talked about that gap earlier? There's a little bit of a gap here. Okay, so I'm not going to put the 3x right here because, don't write that part down, okay? Just give me a second. I'll tell you when to write. Because watch what happens. When I subtract these, am I going to be able to go 4x squared minus 3x? Are they like terms? They're not, okay? So I can't put it there. So watch what I'm going to do. What I'm going to do is I'm going to add the 3x to this one. I wish they wouldn't have done this on the very first example. I don't think that was very smart of them to do. They should have had one where you didn't have to worry about moving something over, because there are problems like that where you're not going to have to move them over. But in this particular case, they did. I think it's kind of weird that they did that. But anyway. Do you understand why I put it under the 3x? Because I can only add like terms together. This is a 3x. I can't put it underneath a here because I can't add those together. So that's obviously different than what we did here, but it's the same basic idea, all right? I can just add those together. So now here's what I'm going to do. I'm going to go 3x cubed minus 3x cubed. What is that? What is 3x cubed minus 3x cubed? It's 0, isn't it? I don't have to put the 0 there. I'm just not going to put anything there. Now, I got to subtract this. Now, what's going to go here? Nothing. Or what? 0x squared. See how I filled in the gap? Remember I talked about that gap earlier, right? So there's that 0x squared. So what is 4x squared minus 0x squared? It's just 4x squared. Let's keep subtracting. X minus 3x. What's 1x minus 3x? Negative 2x. Good. So what do I drop right here? Negative 2x. We'll do a few of these today, okay? So the first time, I always get the looks that I'm getting right now, all right? Some of you guys are hanging in there. Some of you guys have already lost me, which is okay for right now, all right? We're going to do these several times so that you kind of get the idea, all right? First time is always weird when you do this kind. So don't feel like, oh, I'm the only person that doesn't know how to do this. No, you're not, because every year I teach this. Most of the class is like, doesn't have a clue what's going on the first time we do it. But then you do it again, you do it again, you do it again. Then you're starting to get the hang of it. And you're like, okay, now I think I know what's going on. All right, so just bear with me. Just write the stuff down so at least you have it down and you can practice it when you get home. All right? So now, where are we? We're here, aren't we? All right, actually, we're at the 92 because we brought everything down, didn't we? Okay, well, I guess we're still at the 9. We just subtracted those. We're still at the 9. So what did we do on this one? We brought down the 2. So what do you think you're going to do here? Bring down the 7. You got it. Okay, and that's a positive, so we put plus 7. Now, what do we do here after we brought down the 2? We said, how many times does 15 divide into what? 92. So what are we going to do here? How many times does x squared divide into this whole thing right here? Okay? And actually, we can just do the first one. How many times does x squared go into 4x squared? So let's do it over here. How many times, let's do it right here. How many times does x squared divide into, right, 4x squared? Or it's 4x squared divided by x squared. 4x squared divided by x squared. What is that? What happens here? The x squared is canceled out. So how many times does x squared divide into 4x squared? 4 times. So it's like this. It's like, how many times does 15 go into 92? Well, 6 times. So I put the 6 up here. So what am I putting up here? 4. All right, let's do that in red. It would be. Yep, it comes out to be a positive 4. See how this came out to be a positive 4? Then this is going to be a positive 4. So we put plus 4. There are times when you do the subtraction and it does come out to a negative. So you would put minus. Not in this case, though. Okay? All right. We're almost done. So now, what do we do? We said, okay, 15 goes into 92 6 times. What do we do with that 6 and that 15? Well, not yet. What do? We multiply them together, right, which is 90, and then we subtracted. So what are we going to do here? We're going to take this whole thing, multiply it by this, and subtract it. It's kind of what we did up here. So let's take that whole x squared. Let's get rid of this. Let's take that whole x squared plus 1 and multiply it by x squared plus 1. And we're going to multiply it by, actually, I'm sorry. What did we do here? We went 6 times 15, correct? So what are we going to do here? 4 times x squared plus 1. You see that? And then what's that going to give you? 4x squared plus 4. What do we do with that 4x squared plus 4? We subtract it, just like we did here. We went 6 times 15, which was 90. What do we do with that 90? We subtracted it from this. So 4 times x squared plus 1 gives us this. What do we do with that? We subtract it from this. So I'm going to go 4x squared. Now again, this is plus 4. Do I want to put the plus 4 underneath that minus 2x? No, because I can't add those together. I can't add those like terms or subtract those like terms. So I push it over a little bit. I push it right here. And we're almost finished. Let's see what happens. 4x squared minus 4x squared is 0. This is going to be a 0x, right? Because we need something to subtract it from. So negative 2x minus 0 is just negative 2x. And then bring down this. What do we get here? Correct. It's going to be 3 because it's 7 minus, remember that minus? Because I almost put 11 there. But I got to remember, it's 7 minus 4. 7 minus 4 is 3. Now, can I go negative 2x divided by x squared? No. All right? So that is my what? That's my remainder. I'll just put r. So how do I write the remainder? What did I do over here? I took that remainder and what did I do to it? I put 2 over whatever you're dividing by, right? What am I going to do with this remainder? Put it over what? X squared plus 1. So here's how I write the remainder. Since it's minus, I'll put minus, and then I'll put 2x. Actually, let's do it like this. Let's put a plus, but then put negative 2x plus 3 over, what are we dividing by? X squared plus 1. And that crazy looking thing right there is the answer to that division problem. Believe me, I understand. I remember. I do remember. I told you yesterday when I was in that college class, when the professor showed us how to do long division, I thought, that's crazy. I've never seen anything like that before. But then after you do it a while, it starts getting a little bit better. All right, we're not going to dwell on that. You can always go back and watch the video, pause it, think about it, write the stuff down, all right, if you want to do that. Let's do another one. And we're not going to use that regular long division problem as a guide. So this says to divide, let's change this to white. This is example 14. Go on, get out there. There we go. So this is example 14. So it says divide x to the 4th minus 3x cubed plus 2x minus 5 divided by x squared minus x plus 1. So we got to set up a long division problem. Which one's going to go in the box? Yep, it's the x to the 4th stuff, okay? So we'll put all that in here. But before we do that, let's take a look at it. This is what I talked about earlier about the gap again, all right? We started off with an x to the 4th this time. Then the next one down is x cubed, which is good. what should the next one be? An x squared, but we don't have an x squared. So how am I going to write it? I need to put it in there, but how do I write it? Put a 0x squared, exactly right. You see that? If I have x to the fourth, I got to have an x cubed, and I have to have an x squared. Well, I'm going to make that x squared a 0x squared. So it's still in there, but it's still 0, right? And then the rest is good. The next one's an x, and the next one's just the number. So here's how I'm going to write it. X to the fourth minus 3x cubed. There's 1. I only need 1.5. Well, no, that's 1 after. I said how many after the first one? Okay. What's this going to be? Plus 0x squared, and then plus 2x minus 5. Everybody see what I did? I went in order, and I filled in all the gaps. There was a gap with that x squared. So what did I make it? I made it a 0x squared. Everybody okay with that part? Yeah, that was kind of the easy part to this. And then what are we dividing it by? X squared minus x plus 1. Everybody good? Yeah, we're just setting it up. We haven't even done anything yet, but that's okay. So now, what do? How many times does x squared, just take the x squared, forget the rest of this. How many times does x squared divide into x to the fourth? If you can't do that in your head, come over here off to the side and do it. So x to the fourth over x squared. What is that? X squared, that's right. That's x squared because this, two of those x's go out, divide into two of those x's or cancel out with them. I got an x squared. So what's going to go on top? No? An x squared. Right, the x squared. That's going to go on top. So how many times does this go into this? X squared times, we put that on top. Now what do? We take the thing on top, multiply it by the thing on the outside, and then we're going to subtract it. Right? Let's see if we can do this in our head. Do you think you can without writing it down? Let's try it. This x squared times this stuff right here. So what's x squared times x squared? X to the fourth. And then x squared times a negative x. What's x squared times x? X cubed, right? And I can put it under here because I got an x cubed. And let's do one more. X squared times 1. 1x squared. And I can put it here. Plus 1x squared. See how nice it is to have that 0x squared there? Because now I could subtract the like terms from each other. So this time we don't have a little gap like we did on the other one at that point. Makes this one just a little bit easier. Now what do we do with these? We subtract them. So let's subtract. I'll give you some time to catch up. All right, everybody got this written down so far? All right, now what do? Let's take a look up here. I subtract, right? And again, I put that in parentheses because you're subtracting all three of these things. That's why I put in parentheses. So x to the fourth minus x to the fourth is 0. I don't have to put it down. You just know it's going to come out to 0. Let's do the next one. Negative 3x cubed minus a negative. What's minus a negative? What's always minus a negative? Huh? Minus a negative? If I go negative 3 minus a negative 1, what happens to that minus a negative? Yeah, so it becomes what? Plus, right? Okay, a little slow on that one. You guys knew that, all right? So what is negative 3 plus 1? It's not 2, it's negative 2. So what is negative 3, 3x cubed, minus a negative x cubed? It's negative 2, what? X cubed. All right? That's probably one of the more confusing ones when you have a minus and negative. But really, minus and negative is plus, so it kind of makes it easy. It's just negative 3 plus 1. Negative 3 plus 1 is negative 2. Negative 2x cubed. Now we bring down the next thing. All right? So what's 0 minus x squared? What's 0 minus 1? It's negative 1 what? X squared. It's not x2. It's x squared. Oh, did you? Okay, it sounded like you said 2. All right, so we're done the subtraction. Now what do we do? Bring down the next number. Good, just like a regular division problem. And so we put a plus 2x right there. And now we start that routine all over again. So this is one step. What we just did right there is basically one step. So now we do it again. We say, how many times does x squared divide into negative 2x cubed? If that's confusing for you to do it in your head, write it down. So again, we're going to come over here. We're going to put negative 2x cubed. What are we dividing it by? Just the x squared. All right, and let's see what we get. Well, you're going to have a negative 2. This is x cubed over x squared. What's x cubed over x squared? It's just an x, right? Because 2 of these x's cancels with 2 of these. I'm left with 1. I just get negative 2x. Everybody see it? So how many times does this go into this? What do we do with that negative 2x? Where do we put it? Put it on top. That's right. So we put a minus 2x. Remember I said on the other problem, sometimes you will get a minus when you do that division? Oh, one more. One more.
We are in the fight against good and evil at this point in time. Our awesome cheerleading ladies are right now in the competition on Delaware Online with the dreaded St. Mark's folks who have beat us in many different areas, but this one they will not. So I am fully authorizing all classes, all ages, all levels, to spend time, especially since they are
Not now. We're not doing it in here. Do it after you leave.
But they do not have the willpower that we do. So all classes, all grades are authorized at this point in time by the headmaster to pull their phones out.
I think this counts as 2 announcements.
Full time and make sure that we, Red Lion, the Christian school, can go ahead and win this competition. Thank you very much for your attention to this important matter.
All right, let's continue this. We're right in the middle of it. We're not getting out now, okay? So here we go. So, am I going to do what? Not until we subtract. After we subtract, then we'll bring down the negative 5. Good question, though. Okay? I'll prop this up here. All right, so now we put this up here. What do we have to do to figure out what to subtract? I got to take this and multiply it by this thing right here. All right, so we did it once already, right? We did it with the x squared. Now we're doing it with a negative 2x. And we're going to put it right here. So let's do it. Negative 2x times x squared. That's negative 2x cubed. All right? Then we go negative 2x times negative x. Well, what's a negative times a negative? It's a positive. What's 2x times x? It's positive, so we put plus. What is it? What's 2x times x? 2x squared. Got one more. So negative 2x times positive 1. It's just negative 2x. All right, so that's our multiplication. Now we do our subtraction. Putting that parentheses there is super important, so don't leave that out. So here we go. We got negative 2 minus negative. What's minus a negative again? It's plus. What's negative 2 plus 2? 0 x cubed. Did you notice every time that first one comes out to a 0? And it should. All right, let's do the next one. Yes. Let's do the next one. Negative 1x squared minus 2x squared. What's negative 1 minus 2? Negative 1 minus 2. Negative 3. That's negative 3. So what's negative 1x squared minus 2x squared? Negative 3x squared. What's this going to be? 2x minus a negative, which is plus. 2x plus 2x is, aha, we went over.
Would Roman Jones and Ariel in the
I
audience
knew
come
it.
to office?
All right. Oh, no. Guys are out a lot of money. I'm going to cash in, though, so. All right. So there's what we get. Now, Clea, what do we do? Now we can bring down that minus 5. We're going to do it one more time, okay? So here we go. I'm going to go a little faster because time's running out. I'll still explain everything though, okay? So here we go. How many times does x squared divide into divide into negative 3x squared? So what do? We go negative 3x squared divided by x squared. All right, it's it. It's not negative 3x, it's just negative 3. So that's negative 3. So where do we put that negative 3? Up top. Put it right there. And then we multiply and then we subtract. Then we're going to have our remainder. So this is the last time we have to do this. All right? Put a minus, put a parentheses. That's super important. I can't stress that enough. Now let's do the multiplication. Negative 3 times x squared is negative 3x squared. Negative 3 times negative x. Negative times negative is a positive. 3 times x is 3x plus 3x. Negative 3 times positive 1 is negative 3. See, once you get the hang of this, it's not all that bad. At first, though, you got to take it a little slow. All right? Let's do the subtraction, and then what we have is our remainder, and then we basically have our answer. Okay, we'll have this part of it, then we'll have a remainder, and here we go. Everybody watch. Negative 3x squared minus a negative. What did I say will happen to these first terms every time? They're going to go to 0. And does it go to 0? Yeah. Sure. Negative 3 plus 3 is 0. Let's do this one. 4x minus 3x. That's easy. What's 4 minus 3? 1x. And then negative 5, again, here we go again, minus a negative. What's minus a negative? Positive. So it's negative 5 plus 3. What is negative 5 plus 3? It's negative 2. And you just write down minus 2. So what is this? That's our remainder. All right, because you can't go x over x squared. Technically you can, but it's a fraction, and you're not going to put a fraction right there. That's our remainder. How do we write the answer with the remainder? We put plus what? The x minus 2, the remainder, over whatever you're dividing by. What are you dividing by here? X squared minus x plus 1. And that thing, it's crazy looking, but that thing is your answer right there. Like I said, when I was in Calc 2, we actually used this stuff, okay, to get an answer to one of the calculus problems. All right, if you ask me, how are you going to use this in the real world? You're not. I'll tell you right now. Not in the world that you're going to live in, unless you take calculus, unless you do problems with really upper scale, math. You probably will not have to do this, but it's okay. It's good for us to think. All right, we're here to learn to think. All right, it's not just about how we're going to use this. Did I tell you a story? One time, it was a different school. This girl said, I'm not going to do any more homework. I'm like, oh yeah? Why not? She said, well, my mom said she doesn't use this stuff, so I don't have to do it. So her mom told her she didn't have to do any of the work. I'm like, well, that's fine. You're going to fail the class, but if that's what you want to do, that's your decision. If your mom's okay with that, then that's how it goes. I can't remember. I knew you were going to ask me that. Can't remember exactly how she ended up. I don't know if she transferred out of that class or what the deal was. But I couldn't believe that she came to me and her mom says, I never use this stuff. You'll never use this stuff, so you don't have to do it. Look, there's a lot of stuff you learn in life. A lot of stuff you learn how to do, or like this, that you may not use. Okay, you may not make money doing this. Now, I use it because I teach it. But have I ever used it in a real practical situation in my life? Never. I've never had to divide polynomials in my life until I'm telling you how to do it. But it makes you think, all right? It just helps you develop your brain. And that's what's good about math. You know, people all the time, say, why do I use this? My whole life, except for 10 years. I had a 10-year span when I was teaching the media stuff. Were you guys around when I was teaching photography and video? When we did the magazine, when you did videos. Were you guys around for that? You're probably younger, at least middle school, I'm sure. Maybe elementary school, I don't know. Did you guys ever get a magazine passed out to you? Yeah, he was on the magazine, but he was young though. He was in elementary school probably back then. But anyway, for 10 years, I didn't have people asking me, when are we going to use this? When are we going to use this? When I taught photography and video and desktop publishing, we use that stuff all the time, right? You take pictures all the time, you take videos all the time, learn how to edit. Yeah, I was never asked that question. But in math, every day almost, it seems like, when are we going to use this? And I've just come to the conclusion just to say, this helps you think. Are you ever going to have to go somewhere where you don't have to think for a job? Maybe. There's probably some government jobs out there where you don't have to do anything. You just sit there, blah, okay, do nothing. But your whole life, you're going to have to think. You got to drive to work. You got to think. Everything you do in your life, you got to think. This helps develop your brain, and it helps you learn how to think. It helps you become a problem solver. And you're like, well, I'm not going to always do math all the time, but you got to solve problems every day of your life. You're going to have a situation where you got to decide, you got to look at it, and you got to go through a series of steps. It might take a second or less than a second to go through those steps in your head when you're driving. You got to think, okay, if I do this, it's going to have repercussions. If I do that, that's a good thing. If I do that, it's a bad thing. You're going to have to make decisions. This helps you think, all right? This helps you become a problem solver. Whether or not you do this in the real world, it doesn't matter. It's still good for us to be a problem solver. Somebody give you instructions, say this is how you do something, and then you take it and then you do it. Almost every job that you're ever going to have in your whole entire life, even you work at McDonald's. I remember I worked at McDonald's. Nothing wrong with working at McDonald's, okay? But they tell you this is what you have to do. This is how you do the register. This is where the buttons are to push for a Big Mac or whatever, okay? This is how you do the fries. This is how you flip the burgers. I never had to flip burgers. I was always at the register. But anyway, you have to be able to take that information and process it and do what they tell you to do. That's what this is doing. Did you know that? This is stuff that you probably think you'll never have to do, but I'm showing you how to do a particular task, which is a task that you've never done before that you don't know how to do, and you have to learn how to do it. That's what life's all about. It really is. Okay? So I can tell that that's probably what you were thinking when you were doing this stuff. Like, I'm never going to use this, Mr. Hamrick. Why am I learning this? You're learning how to learn. And that's what we're here to teach you, okay? Not just learning the subject. Yeah, sure, the subject's important. Do people actually do this? Yeah, there's somewhere out there in some job somewhere that they have to do this. Are they doing this every single day? Of course not. They probably got computer programs to do that. But people have to program the computer to be able to do stuff like this. So sure, there's people out there that do, but that's not why we're teaching this. We're teaching this so that you can learn how to learn, all right? I don't know if that makes you feel any better about why we're doing this stuff. Probably not, but it's true. And I'm not just blowing smoke, all right? It's absolutely true. Learning math, especially in high school, you're learning how to solve problems. You're going to have to solve problems the rest of your life, all right? So let's learn now. I think it's good. It's kind of fun. I like taking something that looks crazy like that. Look at that. Walking in the door, before you walked in the door, did you think you'd ever be able to do something like this? Probably not, all right? But now looking at it, you're probably still thinking, I don't know how to do this thing. But with time, with practice, you will be able to do this fairly easily and fairly quickly. Did we need a calculator to do any of this? No, we didn't, okay? On that other one, you're dividing by 15. I don't always divide by 15. Do I know how many times 15 goes into 842? No, I have no idea, right? I'd have to use a calculator, right? Or I'd have to do that long division stuff. With this, I don't need a calculator at all. All the arithmetic was pretty easy, I think, right? Because we've learned all that. We've learned how to divide these things. We've learned how to add and subtract negative numbers, okay? So all this stuff you should be able to do without a calculator. I think it's kind of cool. Makes you look kind of smart, right? Show your parents you did this today. They're gonna like, wow, you're really learning a lot of hard stuff in there at Red Lion, all right? It's really not that hard, though. Don't let them in on the secret, though, all right? Make them believe that you're doing something really, really hard, okay? But I think it's kind of cool when you just sit back, you look at it, and like, wow, that's a lot of stuff. It looks like I'm some kind of engineer or something, all right? But It's just long division. That's all it is. All right, enough of that. I don't know why I started talking all about that, but I think it's good for us to do. All right, let's see. Did I write down? I didn't write it on my notes. Let's look at the lesson plan. Dividing polynomials. Did you guys already do 89 to 95? You didn't do it. You didn't do those. So let's do those. 89 to 95. That's our assignment, okay? So let's write that down. 89. Hope everybody remembers. 89 to 95. And it's still section R-4, and we'll call it D. It's the fourth homework on section 4, so we'll call it D. All right? We'll go over those tomorrow.